Welcome to week 12 with Mrs. Bibb. Remember, although this document says that it is for Algebra 2 honors, this is also for my regular Algebra 2 students. So don't forget that. Today we're going to be learning how to solve quadratics. Make sure that you fill in your table of contents and complete your warm-up. And the warm-up for my regular Algebra 2 will be different, so don't be alarmed. If you'll please pause the video and write down the definitions that you see that I have typed here. If you will write down what's in red, notice it says to find the x-intercepts, use Desmos on your homework and Desmos on the notes. That's what I'm going to use. You may want to pause the video when I'm doing that portion and make sure to use Desmos as well. The zero product property. It's very important that you remember what the zero product property is. Make sure that you understand that the zero product property is when you multiply two expressions, A and B, if A times B equals 0, then A equals 0 or B equals 0. So in the Algebra 1 textbook, when it teaches this, it talks about this product of binomials. And it says, since the product of A times B is equal to 0, then A equals 0 or B equals 0. And then you solve each of those individually to get the solutions to this problem. So the solutions to the initial problem that I gave you are -7 and -6. Those are my solutions. Please be careful because the zero product property, product means the answer to a multiplication problem. Students will see a problem like this. So I'm over here in the corner, and they'll do x squared equals 0 or -5x equals 0. Don't do that because this is not a product. You have to actually factor out the greatest common factor before you can do the zero product property, or you have to factor before you can do the zero product property. Now for number 1, 2, and 3, you're going to use Desmos to find the solutions, and you do not have to draw the graph. I've typed that in red. There's a couple things I want you to remember. First of all, this equation must equal 0 before you can type it into Desmos. And all you have to type in is what's on the left side of the 0 or the right side, depending on where you put it. So this is equal to 0. You're going to type x squared minus 11x plus 24 into Desmos to see the solutions. How do you know the solutions? The solutions are where the graph crosses or touches the x-axis. So that's what you're looking for, where the graph crosses or touches the x-axis. If it does not touch or cross, then there's no solution. You may want to add no solution beside of it. You may want to say it does not touch or cross, but I did not write that there. So I have typed in x squared minus 11x plus 24 into Desmos. My graph, and again, you do not have to draw the graph. My graph looks something like this. And in Desmos, if you click, you'll see there's a dot here and a dot here. If you actually click on that dot, then it tells you the ordered pair 3, 0, and it tells you the ordered pair 8, 0. The solutions are the x-intercepts. So 3 and 8 are my solutions for number 2. For 3 and 8 are my solutions for number 1. For number 2, I'm going to move 13 to the other side to make it equal 0. I'm going to type negative x squared minus 12x minus 13 into the Desmos box there at the top left. When you do that, you don't see anything until you start to zoom out so you can see the entire graph. And you will see that the y-intercept of this graph is way down here. So it does not cross or touch the y-axis. So that means this one is no solution. Honestly, I can tell you it means it's no real solution. There are solutions for this, but they're not real. For number 3, I'm going to subtract 5x and subtract 2. I'm going to type that into the calculator or into Desmos. And when I type that in, I see negative 0.250 and 0.666670. That's where this graph would cross or touch the x-axis. So my two answers, I'm not going to use those decimals, I'm going to use my brain. Negative 0.25 is negative 1/4, and 0.666667 is 2/3. Those are my solutions for number 3. Moving on to the next. It says solve the equation using square roots. T squared equals 400. So to get t alone, I would take the square root of both sides. Most students just put t equals 20. But I want you to think about that for a moment. 20 squared is 400. I agree. But is there another number that I can square that would give me 400? And hopefully, in your mind, you said, yes, I can square negative 20 and get 400. When you take the square root of both sides, you have to use the plus or minus sign because we do not know if you are talking about a positive 20 for t or a negative 20 for t, because both of those answers can be squared and give you a positive 400. So I need to make sure to write down, and you should write down also, that when you take the square root of both sides, I kind of abbreviated that a little bit. When you take the square root of both sides, use plus or minus in your answer. Looking at number 5, when I do that, I want 2k plus 3 squared to be alone before I take the square root. I'm going to add 19 to both sides to get that alone. So the quantity 2k plus 3 squared is going to equal 100. Take the square root of both sides. 2k plus 3 is going to equal, I took the square root of both sides, so I can't forget my plus or minus 10. The next thing I'm going to do is subtract 3 from both sides. When you subtract or add to both sides and you have a plus or minus, you want to make sure to put the number that you're adding or subtracting before the plus or minus. So negative 3 plus or minus 10. Now I'm going to divide by 2. K is going to equal negative 3 plus or minus 10 divided by 2. If you would have a radical in this fraction that I'm looking at, or if you would have a complex number in this fraction that I'm looking at, you would stop. But since I have integers, I need to keep going. I need to find the two integer solutions or two rational solutions to this. So if you have rational numbers, you need to keep going. If you have irrational, you can stop, or complex. So keep going. What do you mean by keep going, Miss Bibb? K is going to equal negative 3 plus 10 divided by 2, and K is also going to equal negative 3 minus 10 divided by 2. So K is going to equal negative 3 plus 10 is 7 divided by 2. I'm going to leave that as 7 halves. Or K is going to equal negative 3 minus 10 is negative 13 divided by 2. So my solutions are negative 13 over 2 and positive 7 over 2. Moving on to the next one, I am going to move this 5/7 to the other side by subtracting 5/7. Negative 1/7 p squared minus 5/7 p squared is negative 4/7 p squared. That is going to equal negative 20. I'm going to multiply both sides by 7. So negative 4p squared, because the 7's cancel out, is going to equal negative 140. I'm going to divide by negative 4. P squared is going to equal positive 4 goes into 14 3 times. 2 left over, so 4 goes into 25 times. I'm going to take the square root of both sides. P is going to equal plus or minus. 35 is not a perfect square. The only factors of 35 are 1 and 35 and 5 and 7, and none of those are perfect squares. So my answer is P equals plus or minus the square root of 35. You may stop there and say that's the answer, or it is good to also realize, and I'll go back to number 4 and do this also, that you have negative square root of 35 and you have positive square root of 35. These two answers are equivalent. Either one of those is acceptable. Let me go back to this number 4. That's the same thing for t equals plus or minus 20. That means you actually have solutions of negative 20 or positive 20. So either one of those is an acceptable answer. Next, we're going to solve 7, 8, and 9 by factoring. When you are factoring, just like when you are solving by graphing, you want to make sure that your equation equals 0. Then you want to check for a greatest common factor. And then you want to factor based on whether you have a trinomial or a binomial or form or terms. Okay, so as I look at number 7, it is equal to 0. I don't have a greatest common factor. I can name my A, my B, and my C value. And B is negative 12. Then factors of A times C, so factors of positive 36, that will give me a sum of negative 12. Let me think. Negative 6 times negative 6? And you can do that. You can think about them and only put the one that works in there. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. So that is the pair of factors that I want to use. Remember, and I'm going to put my equal 0 on the right-hand side. It's okay to do that. Remember, since A is 1, I can put my 2 parentheses. I put my middle variable x first, and I put minus 6 and minus 6. Then you do the 0 product property. Add 6 to both sides. X is going to equal 6 for both of these. Now, if you notice, and when I write my answer, I only have to include one of them. I'm writing it above number 7. That is my answer to number 7. But I want to point out something special about this one. Because that same answer occurred twice, and you do not have to write it down twice, this is called a double root. I actually know from this that the graph of x squared minus 12x plus 36 only touches the x-axis. It does not cross through the x-axis. It only touches it. So it's a good clue for me when I'm going to graph something like this, that it would only go through the x-axis at 6, 0. So, and it would point up because my a is positive. But remember that when you have one solution, that solution is called a double root because it touches the x-axis instead of crossing fully through it. Now, let's look at number 8. It does not equal 0, and I would not move the x squared to the left. I would subtract 14x and add 40 to solve this. So I would have x squared minus 14x plus 40 equals 0. A is 1, B is negative 14, and C is 40. So I need factors of A times C, so that would be factors of positive 40. That would give me a sum of negative 14. I need two negatives because I want to multiply and get a positive and add and get a negative. 1 times 40, negative 1 times negative 40, no. Negative 2 times negative 20, no. 3 doesn't divide evenly into 40. Negative 4 and negative 10, that's it. Negative 4 times negative 10 multiplies to give me positive 40 and adds to give me negative 14. So I'm going to have x minus 4, and remember I can do this because my a value is 1, x minus 4 and x minus 14. Do the zero product property. Add 4 to both sides, so x equals 4. Add 14 to both sides, x equals 14. So my two solutions for number 8 are 4 and 14. Now for number 9. I am going to add x squared and subtract 4x. So I'm going to have 6x squared plus x minus 1. A is 6, B is 1, C is negative 1. A times C is negative 6, sum of 1. So I'm going to have a positive and a negative factor, and the positive one is going to be the bigger one. I believe that's going to be 3 times negative 2. 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. Now notice, A is not 1, so I've got to do the grouping method. 6x squared, replace x with positive 3x and negative 2x, and keep your minus 1. So remember, what you do is, let me get a highlighter. You keep this term and this term the same, and then you replace this term, what I highlighted in red, with this factor and this factor with an x beside of it. And then if you would put all that back together, you're going to have the same trinomial when you simplify. Now I'm going to group the first two together. Let's see. Put a plus sign and group the last two together. Let's see. Negative 2x minus 1. The first group has a 3 in common and an x. 6x squared divided by 3x is 2x. 3x divided by 3x is positive 1. The second group has negative 1 in common. Negative 2x divided by negative 1 is positive 2x. Negative 1 divided by negative 1 is positive 1. I'm going to take out the greatest common factor. Remember, I have these the same, so that means I factored successfully. 2x plus 1 times the quantity 3x minus 1. Then I'm going to do the zero product property. Solve for x. So I've got negative 1/2 and positive 1/3. So my two solutions are negative 1/2 and positive 1/3. Okay, for the next group, I am going to pick the easiest ones to solve and kind of work backwards. Now here's what it says, and this is a great example of an SAT question. Which equations have roots that are equivalent to the x-intercepts of the graph shown? So it's kind of a two-part question. First of all, my x-intercepts are -1 and +4. So -1 and +4. I think letter C looks like it would be the easiest to solve. So I'm going to solve letter C first. I can go straight to the zero product property because I have two terms being multiplied that equal to 0. Also, I believe that there could be more than one answer to this. We're looking for which equations, so that could be more than one, it's plural, which of these would have the solutions -1 and 4. So when I solve the first one, I add 1. Right there, that automatically tells me this one's a no. And I subtract 4. So the solutions for this one are -4 and +1. C would not be one of the equations that have the x-intercepts of -1 and +4, which make it equivalent to this graph over here. Next, which one is the easiest to solve next? I think letter D. I'm going to subtract 4 from both sides. I'm going to take the square root of both sides. And when I take the square root, I get x minus 1 equals plus or minus. If you type the square root of -4 into a calculator, what will you get? If you don't know, please grab a calculator or type it in Google, square root -4. See what it says. The calculator that I have here actually says domain error, and that means that this is a no real solution problem. If you get the square root of a negative, there's no real solution. In the next lesson, we're going to find out actually what you should do to complete this problem. There is an answer, it's just not a real answer. So that means D is also not equivalent to the x-intercepts of the graph pictured there. Which one is the next easiest? I'm going to say letter B. First thing I need to do for letter B is to subtract 4. X squared minus 3x minus 4 equals 0. I'm going to name my A, my B, and my C value. I'm going to come over here to the side and work on this problem. Letter B, factors of A times C. A times C is -4, sum of B, -3. I want to multiply and get a negative. That means a negative times a positive. I want to add and get a negative, so that means my negative number needs to be larger in order to get a negative sum. So the only options I have are -4 and +1, or -2, and +2. And -4 and -1, when you add them together, give me -3. Is my a value 1? Yes, it is. So I can go straight to my two empty binomials, put x in the first spot of each one, -4 in the first one, and +1 in the second one. Now I'm going to do the zero product property. I'm going to add 4 to both sides. X equals 4, so far so good. Subtract 1 from both sides, x equals -1. So there's one of these, but it does say equations, it's plural, so there must be more than one. So letter B is a yes. Yes, this one is equivalent. I'm going to do letter A next. When I look at letter A, the first thing I notice is that it does equal 0, so I can begin to solve. The next thing I notice is that I do have a common factor of -2. -2x squared divided by -2 is +x squared. -10x divided by -2 is +5x. -8 divided by -2 is +4. I can go ahead and divide both sides by -2 because I'm solving. I can't do this if I was just factoring, to get rid of that -2. What would be left is x squared plus 5x plus 4 equals 0. A is 1, B is 5, C is 4. I need to make my chart. A times C is 4, sum of B is 5. I can multiply 1 times 4, and that gives me +5. A is 1, so I can go ahead and put my two empty binomials. I can put my x in the first spot of each of those, +1 in the first one or the second one, it doesn't matter. The order of these two does not matter. +4 in the second one. Now I can do the zero product property. X plus 1 equals 0. X plus 4 equals 0. Subtract 1 from both sides. X is -1. Subtract 4 from both sides. X is -4. Are these solutions equivalent to the solutions you see in the graph shown? No, they aren't equivalent. -1 and -4 solutions are not equivalent to -1 and +4. So letter A is a no. So far, only one yes. So I'm going to assume that letter E is going to be a yes, but you can't assume. You have to show your work. So I'm going to subtract 18x from both sides and subtract 24 from both sides. That will give me a 0 on the right-hand side. I'm going to factor out the greatest common factor of 6. We're dividing each of those by 6. I am going to get rid of that common factor. Remember, you can only do this when you are solving. So x squared minus 3x minus 4 equals 0. A is 1, B is -3, C is -4. Factors of A times C, so factors of -4, that give me a sum of -3, and I see that chart over there. -4 times +1 is what gives me -3. I can go ahead and put my two empty binomials, put x in the first spot of each of those. Since a is 1, I do not have to factor by grouping. Put a -4 and a +1. X -4, x +1. And then do the zero product property. Set each factor equal to 0. Add 4 to both sides on the first one. X is going to equal 4. Subtract 1 from both sides on the second one. X equals -1. So my two solutions are -1 and +4. Are those solutions equivalent to the solutions or the x-intercepts on the graph shown? And yes, they are. So E is also a yes. B and E have solutions that are equivalent to the graph shown. Let's look at the next slide. It is an application problem that I would do. Let's see what it's asking me to do. A skydiver drops out of an airplane that's flying at an altitude of 4,624 feet. Use the formula shown. Oh, I want to show this fancy. This says h equals -16t squared plus h sub 0. And I want you to remember that when you see that h sub 0 or anything sub 0, that's talking about the initial height or the starting height. Do we know the starting height? Yes. The airplane is flying at an altitude of 4,624 feet. So the answer to letter A is really quite simple. It is h equals -16t squared plus 4,624, because that is the starting height, of the skydiver. For letter B, and this is a little typo here, but is it possible for the skydiver to wait 18 seconds before pulling the parachute cord? So after the skydiver jumps out of the airplane, would it be possible for that skydiver to wait 18 seconds? Let's talk about what 18 seconds means. In the equation for letter A, I have h, which stands for height, and t, which stands for time, in seconds. See, it says t seconds. Where am I going to put 18 in that equation? Am I going to put 18 in for h or 18 in for t? Remember, h is height in feet. It says it up here in letter A. And t is time in seconds. So hopefully in your mind, you just said put it in for t, Miss Bibb. So that's what I'm going to do. And some of your SAT questions that you see, that's all you have to do. Is you have to know to substitute your number given into the correct spot in the equation. Now I'm going to do order of operations. You're welcome to pause this because I know you know how to do this problem. I'm going to multiply next. -5,184 -560, and that is measured in feet. So the answer to this is a yes or no. Is it possible for the skydiver to wait 18 seconds? What is the answer if you get an answer of -560 feet? No, the skydiver cannot wait 18 seconds. And it says explain. If the skydiver waits 18 seconds, they will hit the ground. Mathematically, it says they're going to go -560 feet below the ground, but I don't know if that's going to really happen because of course, the body would make an impression on the earth, but I don't know, I don't believe that you could go negative 560 feet below the ground, hit the ground. And that's the answer to letter B. That wasn't quite so bad. Students see word problems and they think that they're really difficult. So your week 12 practice this week comes from the textbook. This is in chapter 3, so you'll look at the chapter 3 PDF if you only have the PDF version of the textbook. Your assessment will have some time within the near future. There's the answers, and it shows you where to find the answers. And there's your answer to your warm-up. And I hope you have a wonderful week. Make sure you get everything done. And please reach out to me if you need any help at all. I am here to help you in whatever way that I can. Have a wonderful day.